Geometry 10.6, page 498. 498. This is called dilation. Have you ever had your eyes dilated? They go and they put the little drop in your eye, and your pupil gets really big, and you can't see because there's way too much light. Your eye dilates. It gets bigger, okay? So on dilations, things are going to get larger or smaller by a certain amount. Now, on an isometry, things did not get bigger. Things did not get smaller. The object itself was preserved. Side length remained the same. Angles remained the same. Order remained, all that stuff, nothing changed. On dilation, a dilation is not an isometry, okay? It does preserve some things, but it's not an isometry. So a dilation is a transformation defined by its center, P, right here, and scale factor, K being greater than 0, such that P and every other point is mapped onto A prime. Okay, so all this is saying is this. If I draw, I won't run a room. So if this is my center of dilation, what I do is I go like this. I draw a line that goes up like this, and I draw a line that goes through there. Does that make sense? So if it's going to get bigger, let's say it's going to double. So my dilation is times 2. This distance is going to double again, right there. So I continue this out. There's that new point, Z prime. Y is going to double. It's going to come up to here on this line. There's my new Y prime. X is going to come up right here. So here is it's a different size. Does that make sense? If I doubled it, if this length doubles, this length doubles. This length should be twice as big. This length should be twice as big. The thing is going to double in size. Okay, if it was, let's do a different color here. Do black. If my dilation was 1/2, okay, this distance here would be cut in half. This distance here would be cut in half. This distance here would be cut in half. Here is my new deal. Y, Z, 1, 2, 3, 1, 2, 3, whatever. This is a dilation getting smaller. This is a dilation getting bigger. Okay, times half times 2. This is the amount of dilation from the point of dilation to my object. Now, some things remain the same in here, okay? Let's see. I think over here, characteristics preserved by dilation on page 500. Collinearity of points. Okay, so if I have, I can't get these pins off. So if this is my P, and this is my line A, B, and C. Well, let's bring that down a little bit here. Okay, so we do our detail like this. Get back over here, boy. Like this. Here's my ABC. Okay, here's my point P. If let's say I double this thing here, this comes out to here. This comes up to here. So here's my new line. Wow, that didn't work well. This here is to there. This here is to there. Yeah, that didn't work well at all. No. Okay, so this is A prime. B is going to be, it's going to be also right here. That line would go like this. So B would be right here, and C would be right here. So it's still B is between A and C. This distance is doubled here. This distance is doubled here. This distance is doubled here. Okay, but collinearity is preserved. Okay, betweenness of points. B is still between A and C. Angle measure is the same. This angle didn't change here, here, and here. This angle here, and this angle here, same. This angle, and this angle. these are similar triangles. You understand? Side distance is the same, but angles are the side distance is different. Angles are the same. And then parallelism. If I had like a parallel deal, whatever here, and it got bigger, everything's still parallel. That's what they're saying there. Okay? So this is pretty easy. You take your original, and you put your point P, and you do what it says to do. So, or you look at it and say, what happened? Like on number 1, I think you have the triangle point. So what is going on? From the original to the second, it's being reduced. It's getting smaller. Okay, on the second one, the black is the original, the orange is the other one, so it's being enlarged, and it's greater than 1, okay? Reduction on number 3, okay? You see that. And then, so anyway, just have to follow the instructions. All you got to do is 1 through 18, and then 20 through 30, evens on 20 through 30. This is pretty easy stuff, okay? See if I can turn this off.